Hey, everybody. I wanted to take you through several IXL questions that I want you to work on between now and next Tuesday. Again, they are J2, J3, and J4. So let's start here with J2. And I know you guys can read along, but I want to just read it so we can go through it together. Three states of matter: solid, liquid, and gas. And in each state of matter, the particles behave in a different way. And we've talked about that a lot on the PowerPoints, okay? In a solid, again, remember the movie theater, people in your seats, they are packed together tightly. In a liquid, close together, but they can slide by. Again, in the PowerPoint, our example was the lobby of the movie theater. So you can be up and walking around, but it's still, you might have trouble getting around. And in a gas, the particles are flying everywhere, again, like outside of the movie theater where you have no restrictions. So for this first question, they would like us to drag and drop what the particles would be. So here we have some movement, still somewhat compacted together, but they're moving a little. In the middle, they're all lined up together. Kind of, I always think of like if you've ever watched the Ohio State Marching Band. And then this last picture, they're flying all over the place. Okay, so either do this with me, and you are welcome to, or just watch. Where do we think a solid would go? Well, again, the solids are packed the most tightly together, so they would go here. Okay, then the liquid, we have some movement, but not totally free, so that would go here. And then the gas would be flying all over the place, so that would go here. All right, we are brilliant. Now, you were going to have a little video probably on, let me check my calendar, on Thursday that will talk about plasma. But plasma is like a fourth state of matter. We don't talk about it much. But this is some good information about it. It's found in our light bulbs. Plasma happens when lightning strikes, and sun and lots of stars are made from plasma. So you've probably seen plasma, but not known it. All right. So let's look at this next question. Particles behave differently because they have different amounts of thermal energy. Okay. Thermal energy is also known as heat. And if you remember back to the PowerPoint, we also had the kinetic theory of matter, kinetic, meaning moving. All right, so in a solid, again, the particles are held together tightly and they don't move around freely. So a solid keeps its shape. Think your desktop, a table, wherever you're sitting right now, anything that is a solid keeps the same shape. So even though they cannot move past one another, they're not totally still. Remember the people in the movie theater, there we go, shaking a little bit. Okay, so they're moving in place. So we're going to pick everything that is true. So particles in a solid have thermal energy. They are packed together tightly, or they are completely still. All right? Thermal energy. Okay. If you remember back to the PowerPoints, all particles in every state of matter are moving some. None of them are not moving at all. So they do have some thermal energy. Are they packed together tightly? I'm going with yes. And are they completely still? No, they're moving, vibrating, even just the slightest bit. So let's submit and see how we do. Woohoo! All right. What happens when you heat a solid? All right. That increases its thermal energy, the heat. Again, thermal energy, think of heat. So when solids have more thermal energy, they start vibrating more quickly, which makes the temperature go up. Once it reaches a certain temperature, it's going to be the melting point. And we've talked about that during our properties. So if our solid is ice, okay, if we raise the temperature let's say in Fahrenheit, because we're more accustomed to that than Celsius. If we raise it to 32 degrees Fahrenheit, it's going to start changing state. It's going to go from a solid ice into a liquid, water. So the particles gain enough thermal energy to move around more freely, and that's what we're showing here. If they remain close together, okay, but as you can see, but they're sliding past each other. So once they finally break out of this fixed position, they have changed state. So let's look at this question. Which of the following happened during a change of state? The substance melts and becomes a liquid. The particles in the substance move far apart, or the number increases. So what do we think? Well, are the number of particles going to increase? No. The number of particles stays the same. It just is in a different arrangement. Okay? Are they moving far apart? Well, not really far apart. Okay? They're still together. They're just moving a little more. So let's just try this top one. It melts and becomes a liquid. And we'll hit submit. And we got it. Good. All right. We're going to stop there. Tomorrow we will talk about sublimation. That was a little bit in our PowerPoint that you just completed. All right. Hopefully that helped. Keep working. I'll do a little IXL video every day, but keep working hard. Take care.